first step is to arrange the data in order. It can be ascending or descending. It depends on you. This will make it easier for you to tally the data. After you have arranged it, we can now proceed with the next step. The step 2, which is to determine the number of classes. To determine this, we should find first the difference between the highest value and the lowest value, and that will be our range. In our case, the range is 44. We need this to determine the number of classes. The objective is to use just enough classes. We can determine the number of classes, which is denoted by the letter k, using the 2 to the k rule. This will enable us to select the smallest number, k, for the number of classes such that 2 raised to the power of k is greater than the number of observations. This tutorial is very detailed, complete and comprehensive that will let you understand how statistics really works from basic to advanced. After determining each of these terms' definition, let's now move on to the construction of frequency distribution table. In constructing a frequency distribution table, there are actually 2 general types of frequency distributions, the categorical frequency distribution and the grouped frequency distribution. Let's start first with the categorical frequency distribution. The categorical frequency distribution is used to organize nominal level or ordinal level type of data. Here is a sample of how a categorical frequency distribution looks like. So, how to make it? Here are the following steps to create one. Step 1. Construct a table with labels such as the class, tally, frequency and percentage. Step 2 is to tally the raw data. Step 3 is to convert all the tallied data into numerical frequencies. This should be under the frequency column. Last step, the step number 4 is to find and determine the percentage. Just like what I have told you a while ago in the definition part, this is how it is computed. That's how the categorical frequency distribution works. This is how it looks like. In my case, I don't have the manual tally of the data because I used Microsoft Excel for this picture. Isn't it simple? Right? Let's now move to the grouped frequency distribution. Grouped frequency distribution is actually used when the range of the dataset is large. The data must be grouped into classes, whether it is categorical data or interval data. For interval data, the classes is more than 1 unit in width. The procedure for constructing frequency distribution will be done step by step with an example. The following data represents the ages of the members in a certain church. Construct a frequency distribution and determine the following: range, number of classes, class interval, midpoint, class limits, class boundaries, frequency, relative frequency, percentage, and the cumulative frequency. First step is to arrange the data in order. It can be ascending or descending. It depends on you. This will make it easier for you to tally the data. After you have arranged it, we can now proceed with the next step. The step 2, which is to determine the number of classes. To determine this, we should find first the difference between the highest value and the lowest value, and that will be our range. In our case, the range is 44. We need this to determine the number of classes. The objective is to use just enough classes. We can determine the number of classes, which is denoted by the letter k, using the 2 to the k rule. This will enable us to select the smallest number, k, for the number of classes such that 2 raised to the power of k is greater than the number of observations. In our case, the number of class is 6. That's enough number of class. Since we already determined the number of class, we can now determine the number of class interval, or the sometimes called the width. Generally speaking, the class interval or the width should be equal for all the classes. The classes must cover all the values in the raw data. Class interval is generated using this formula. In our case, if we use this formula, it will lead us to 7.33, which we should always round it up. It will be number 8. Why round up? Not round down? Or even basically follow the rules of rounding of number. I emphasize the directive to round up because it will make us cover the remaining decimals points, which in our case is 0.33. If we will going to round it down, it will not be covered and will just have some statistical bias. Some manipulations have done already, and that should not be how statistics is done. Next is to select the starting point from the lowest class limit. The starting point can be the smallest data value or any convenient number less than the smallest data value. In our case, 11. Next is to set the individual class limit. We need to add the interval to the lowest score taken as the starting point to obtain the lower limit of the next class. Keep adding until we reach the 6 classes. So, here are our class limits. Here you can see that our lowest number, which is 11, is actually part of the first limit, while our largest number, which is 55, is part of the last limit. If you're going to cut, we have acquired a total number of 6 class limits, which came from out number of classes, as part of the computation on the suggested class interval. After obtaining the class limits, we can now compute for the class boundaries. To obtain the class boundaries, what we only need to do is to subtract 0.5 from each of the lower limit and add 0.5 from each of the upper limit. Here is now our class boundaries. Next is to get the frequency of each class limit from our table of raw data before. So, here is our frequencies per classes. After obtaining our frequencies, we can now get the relative frequency. It is computed by dividing each frequency by the total frequency. So, here is our relative frequencies. Next is to determine the percentage by multiplying all the relative frequency into 100. After the percentage, the next column would be the cumulative frequency. It can be found by adding the frequency in each class to the total frequencies of the classes preceding that class. So, here is now our cumulative frequency. Last part of the frequency distribution table is to determine the midpoints. This can be get by computing for the average of the lower and the upper limit in each class. So, here is now our midpoints, and at the same time, this serves as our complete frequency distribution table. I think that's it for now. That concludes our video tutorial for today. That is how to create a frequency distribution table. I hope you learned something from this video. Our next video tutorial will be all about stem and leaf plot and the different statistical graphs. If you have some questions to ask, you may comment them below. And if you also want to notice you through shout out, never hesitate to request on the comment section, my friend. I will be happy to notice you.